Alright, so I'm going to start with the static practice problems that I assigned to you. This is problem number 1 right here. Let's read it together. It says, what is the magnitude of electric force between two charges? So there's the big clue right there is what is the electric force between two charges. That's what we're solving for. Q1 has a charge of 5.5 times 10 to the negative 12th, and Q2 has a charge of negative 3.3 times 10 to the negative 13th coulombs. The charges are separated by 0.50 millimeters. So I'm going to go ahead and I'm going to get to my page where I'm going to draw. I'm going to sketch it out, and I'm going to write down the clues that we just read about. Well, first of all, so this is problem number 1, I'm going to write out the electric force. And the electric force is what we're solving for. That's what we don't know. But we do know this. We do know that Coulomb's law is the electric force is equal to the constant K times Q1, which is charge 1, times Q2, charge 2, all over the distance squared. There you have it. So that's Coulomb's law. So let's write out all the clues that we have. And so we already know what K is, and so let's write out Q. So Q1, as it was said in the problem, and you can look back at the problem if you want to, but I have 5.5 times 10 to the negative 12th. So it's 5.5 times 10 to the negative 12th coulombs. And then Q2 is going to be equal to negative 3.3 times 10 to the negative 13th coulombs. And then it also gives me the distance. The distance was expressed as 0.5 millimeters. Alright, off to the side, a little side note, 1,000 millimeters are equal to 1 meter. And we have to convert to meters. Meters is what the problem has to be in. And if you notice, the units, part of the units for the K constant is written in meters. So we have to use meters, so I have to convert. And how we do that is we divide by 1,000. Everybody knows, if you divide by 1,000, every time that you move the decimal to the left, it's dividing by 10. So there's 10 cubed is 1,000, so we move that decimal to the left 3 spaces. So it should look like this, 0.00050 meters. And that's our distance. That's the distance we're going to use. Okay, so now I'm going to move this up a little bit, and then I'm going to plug everything in to our what we had for our Coulomb's law. I'm going to use this equation here and plug it in. Alright, so going off here, I'm going to say electric force is equal to, I'm going to start with my K constant, which is 9.0 times 10 to the 9th power newtons meters squared divided by coulombs squared. Okay, then the charge number 1 is 5.5 times 10 to the negative 12th coulombs. Alright, and then the last one here is charge number 2, Q2, 3.3 times 10 to the negative 13th coulombs. Alright. Draw my big line as straight as I can. And then in the distance here, should be 0.00050 meters, and all of that is squared. Okay, so order of operations, you want to square the denominator first and get that taken care of. And if you were to do that, and then you could take care of the numerator as well. And so I'll do that in the next step. So let's move this up a little bit. So I have this all equal to, I'm going to do the numerator first. So let's say here, the numerator, I've got negative 1.6 times 10 to the negative 14th. And if you wanted to go back and cancel the units, these coulombs are going to cancel out here, and the meters are going to cancel out because they're going to be squared, and you're going to be left with newtons. So that's newtons all over, and when you square this, it turns out it's 2.5 times 10 to the negative 7th. And then you just divide these out, and you end up with an answer of negative 6.4 times 10 to the negative 8th newtons. And then circle your answer. And there you have it. We just answered our first question. All right.